Hello and welcome to the MathematicsKicker. Today I'm going to introduce the theorems without the center. Last time we introduced the center theorems. We introduced 4 theorems with the center, right? And we proved 2 theorems. Then today I'm going to introduce the theorems without the center. Then let's see how it's done. If you haven't watched our previous video, go and watch them in order to understand the Euclidean geometry. We introduced the geometry from the introduction of geometry. We introduced the theorems with the center. Then today we are introducing theorems without the center. Then let's see how it's done. Right. In this case, we have this theorem. In this theorem, you must know this theorem. It's very important to know this theorem. In this theorem, if you have given something of this is a cyclic quad. It's just they did the things, you see. Then now, in this case, we can conclude by saying that angle A is equal to angle B and angle C equal to angle D. The reason is the angle subtended by the same arc. This arc subtended this angle that's subtended by the same arc or angle in the same segment, right? Angle in the same segment. This is a segment, right? Angle in the same segment or angle in the same arc. Angle subtended by the same arc. That is the reason. You can conclude by saying angle A is equal to angle B or angle C is equal to angle D. You must know that the reason is the same segment or angle subtended by the same arc again. Angle subtended by the same arc or angle in the same segment again. In the same segment, right? In this case, let's talk about this theorem. These theorems, we are going to prove it. We are going to prove these theorems. We'll be proving this theorem. Then now, this theorem, it says that the opposite angles of a cyclic quad are supplementary. If ABCD is a cyclic quad, right? If ABDC is a cyclic quad, we can conclude by saying that angle A plus angle D is equal to 180 degrees. Opposite angles of a cyclic quad are supplementary, right? And angle B plus angle C is equal to 180 degrees, right? They are supplementary. This is a theorem. We are required to prove this theorem. The reason of this theorem, opposite angles of a cyclic quad are supplementary. Then if okay, then now let's go to this theorem. We must know this theorem again also. This theorem, if A, B, C, D is a cyclic quad, if A, B, C, D is a cyclic quad, we can conclude by saying that, and this line is a tangent, it touches this circle here, right? Then we can conclude by this angle is equal to this angle, right? This angle is equal to this angle. We conclude by saying that we say there is an exterior angle of a cyclic quad is equal to the opposite interior angle of a cyclic quad. In a triangle, we said that exterior angle of a triangle is equal to the sum of the two opposite interior angles of a triangle. Then in this case, the exterior angle of a cyclic quad is equal to the interior angle of a cyclic quad, right? Then now, that is the reason for this theorem. You must know this theorem. If we are given this angle is equal to this one, you can conclude by saying ABCD is a cyclic quad. But if we are given that ABCD is a cyclic quad, we can conclude by saying this angle is equal to this one. Then again, we have this theorem, and we'll be required to prove this theorem. Remember, in the center theorems, we proved 2 theorems. Then in the theorems without the center, we are going to prove two theorems, this one and this theorem, right? Then in this theorem, it's very important. We call it the tan chord, right? Remember, in the center theorem, we talked about the tan radi. Now we're talking about the tan chord. It says that an angle between a tangent, if this is a tangent, angle between a tangent and a chord, which is this angle, drawn from point of contact, is equal to the angle subtended by the same chord in the alternate segment. In the alternate segment. We call it the alternate segment theorem. This is the alternate segment theorem. This is the angle between a tangent and a chord drawn from point of contact is equal to the angle subtended by the same chord in the alternate segment, right? In the alternate segment, we are required to prove this theorem, and also you must know this theorem. You must know this theorem that these tangents, they are equal. It's fine. Then also you must know about this. You must know about this, right? That equal chord subtend equal angles, like subtend equal angles, right? Then now if we have two triangles, this is the chord. I can draw another angle here. It means I can just extend another one. If they are shared from the same chord, it would give us an equal angle, right? If we have two triangles and they have the inside the circle like this, then now this chord, if these chords are equal, it means they'll subtend equal angle. Another one, let's draw something of this nature. I want to draw this. Then it means also this angle is equal to this one. Angle drawn from the same chord, right? This is the angles drawn from the same chord. Angle drawn from the same, this is a chord, they share this chord. Then now they are equal. Angle subtended by the same chord or drawn from the same chord, right? Then now I'm going to see you in the next video whereby we'll be proving the theorems. Right, then I'll see you in that video. Please like and subscribe to our channel and share with your friends and classmates. Right, Carl Gauss once said it is not knowledge but the act of learning, not position but the act of getting there which grants the greatest enjoyment. I say peace. I'll see you in the next video.